this machine hasn't run in years, left to seize under layers of hardened mud and rust. Today, one craftsman begins the massive undertaking of bringing it back to life. The first step in any full restoration is isolating the power plant. Removing the radiator, steering column, and front chassis components exposes the true condition of the engine. Decades of agricultural work leave behind severe oxidation and thick oil residue, locking threaded fasteners in place. Using an impact driver provides the necessary shock force to break these rusted bonds without shearing the bolts. Coolant hoses and brittle fuel lines must be carefully detached to avoid spilling residual fluids. By unbolting the transmission housing, the engine is finally severed from its heavy frame. A rope hoist manages the dead weight as the final structural connections give way. The cast iron block now sits isolated on a wooden platform. The external tear down is complete. Moving deeper into the mechanics, the upper valve train is the next system to be dismantled. Loosening the rocker arm hardware requires steady, even pressure to avoid warping the delicate structural shafts underneath. Once the assembly is lifted clear, the heavy valve springs and long steel push rods are fully exposed. These rods transfer mechanical motion from the camshaft deep inside the block directly up to the valves. Pulling them out individually protects their perfectly straight tolerances and prevents them from dropping into the oil galleries. Come. Reaching the combustion chambers requires extracting the deep-seated cylinder head bolts. These heavy fasteners endure immense thermal stress and require a long extension to provide sufficient leverage. Once the hardware is free, a pry bar is gently leveraged against the casting to crack the hardened gasket seal. Lifting the massive iron cylinder head away reveals the harsh reality of the internal wear. The exposed pistons and cylinder bores are caked in thick, hardened carbon. This dark fouling is a hallmark of an aging diesel engine, where unburnt fuel bakes onto the metal surfaces and gradually saps compression. To prepare the casting for a complete overhaul, the side-mounted fuel injection pump and remaining valve train hardware are stripped away. The long push rods are carefully extracted and wiped down to inspect for subtle bends that would ruin valve timing. Every gasket encountered here will be discarded as their metal layers crush permanently upon first installation. The block is steadily being reduced to its raw structural core. Stripping the rear of the block focuses on the critical driveline connections. The rusty clutch pressure plate must be unbolted from the flywheel. This heavy component is responsible for clamping the friction disc, transferring the engine's raw torque directly to the transmission. Removing it exposes the heavily soiled rear main seal. housing beneath. This seal is the only barrier keeping pressurized engine oil from escaping along the spinning crankshaft. Over decades of heat cycles, the internal rubber hardens, shrinks, and inevitably fails. The thick, grimy sludge coating. This entire rear plate is the direct result of that failed barrier. Extracting the housing hardware is the final step before opening the bottom end. Breaking the factory seal on the lower oil pan reveals the internal state of the bottom end. A thick layer of congealed sludge coats the lower casting. The internal oil pickup tube, which draws crucial lubrication up into the mechanical pump, is smothered in heavy, black residue. Unscrewing this tube finally exposes the connecting rods and the raw crankshaft journals above. With the connecting rods disconnected, the pistons can finally be pushed out through the top of the cylinder bores. Examining the extracted pistons shows deeply worn rings and significant carbon scoring along their skirts. A solid metal rod provides the even, upward force needed to guide them out without scratching the delicate cylinder walls. Below, an impact wrench makes quick work of the main bearing caps, freeing the heavy crankshaft from its saddles. Once the entire rotating assembly is lifted clear, the dark, oil-soaked iron block is left completely hollow. The foundational teardown is finished, paving the way for intensive restoration. Following a rigorous phase of block scrubbing and deck resurfacing, the upper end demands identical precision. An angle grinder equipped with a high-grit abrasive disc strips the heavy soot baked deep into the cylinder head. Polishing these combustion chambers eliminates hot spots and restores the smooth airflow characteristics vital for efficient diesel ignition. The dark, oxidized crust is carefully ground away from the outer edges, revealing the bright, raw cast iron beneath. The metal must be perfectly flat to accept a new gasket. After lapping the newly seated valves to guarantee an airtight seal, the cylinder head is ready for final reassembly. The polished cast iron shines, completely stripped of its former rust and corrosive buildup. Seating the valve train requires compressing heavy coiled steel to lock the small metal retards onto the valve stems. These springs must exert tremendous consistent pressure to snap the valves shut rapidly against the violent pressures of the diesel combustion cycle. With the valves firmly secured, long threaded mounting studs are driven deeply into the top of the casting. These critical studs will eventually anchor the rocker arm assembly and provide the clamping force needed to hold the head to the main block. The transformation is striking. While the heavy castings are assembled, dozens of smaller structural components undergo severe chemical cleaning. Oxidized bolts, brackets, and an exhaust manifold are submerged in an aggressive solvent bath. As the chemical reaction foams and bubbles at the surface, it rapidly dissolves decades of hardened grease, breaking the molecular bond between the rust and the steel. Meanwhile, mechanical stripping handles the larger exterior housings. An angle grinder rapidly tears through the faded green factory paint and surface rust on the timing cover. Manual wire brushing reaches the tight crevices around the oil cap threads, ensuring no old material is left behind. Finally, grinding the interior flange of the valve cover guarantees a perfectly bare, flat mating surface. Any leftover sealant here would compromise the new gasket. Precision is paramount when preparing the engine's rotating assembly. New piston rings are meticulously spread and seated into their machined grooves. These fragile bands of high-tensile steel form the only barrier between the violent combustion chamber and the oil-filled crankcase below. If they are twisted during installation or positioned without the proper staggering of their end gaps, the engine will instantly lose compression and consume oil. The craftsman checks their fit by hand, ensuring they spring outward with even, consistent tension. Before the pistons can be installed, their crowns must be completely devoid of old buildup. A wire wheel polishing the top of the piston restores the smooth, bare aluminum surface. This step is critical. Rough carbon deposits can retain immense heat, acting like glowing embers that cause premature, destructive fuel detonation. The polishing leaves the metal bright, cool, and highly reflective. Nearby, a tray of dark, dirty solvent shows just how much material was stripped away to reach this standard. With the rings properly tensioned and the final valves prepared, these components are ready to handle thousands of explosive cycles every single minute. The meticulous preparation of these internal parts dictates the future reliability of the machine. The machined block is finally ready to receive its core rotating mass. The heavy multi-throw crankshaft is lowered carefully into the greased main bearing saddles. Dropping this precisely machined steel shaft too forcefully could easily scar the soft bearing shells, an error that would ruin oil pressure before the engine ever fires. A wooden block buffers the hammer strikes, allowing the shaft to be tapped gently into its seated position. Once aligned, thick assembly lube is applied generously to the main bearing caps. This dense lubricant prevents metal-on-metal friction during the crucial first seconds of initial startup before the oil pump can build internal pressure. The caps are torqued securely into place. Finally, the newly fitted rear main seal housing is aligned and driven flush with a rubber mallet, sealing the back of the crankcase. Marrying the pistons to the block is an operation of incredibly tight clearances. A specialized ring compressor tool squeezes the high-tension steel rings flush against the piston skirt. Without this compression, the expanded rings would catch and shatter on the top deck of the cylinder bore. Using a soft wooden handle, the piston is driven smoothly downward, sliding seamlessly from the tool into the freshly oiled cylinder. Working from the underside, the connecting rod must be meticulously guided onto the waiting crankshaft journal. The rod cap is slipped into place, and the bolts are torqued to exact factory specifications. The craftsman checks the lateral play by hand, verifying that the assembly moves freely without binding. Finally, the oil pickup tube is bolted deep into the crankcase, ready to draw fluid from the pan. Sealing the front of the block protects the delicate timing assembly. The heavy metal cover is aligned over steel dowel pins and bolted down flush over a new, bright red gasket. This casing shields the gear set that synchronizes the crankshaft rotation to the camshaft, ensuring the valves open at the precise microsecond required. Moving to the side of the engine, the mounting flange for the fuel injection pump is wiped immaculately clean. Diesel pumps operate under extreme mechanical pressure and demand a perfectly flat, debris-free seal to prevent leaks. As the heavy unit is carefully slotted into the block, a small steel retaining pin is inserted to temporarily lock the internal drive gear. This pin holds the crucial fuel timing dead steady, while the housing bolts are rapidly secured with an impact driver. With the rotating assembly fully sealed, focus returns to the top deck of the block. A thin, multi-layered metallic head gasket is aligned flat over the empty cylinder bores. This specialized dark sheet must permanently withstand the brutal explosive pressures of the diesel combustion cycle without blowing out. Once the heavy cylinder head is clamped securely over the studs, the upper valve train takes shape. Long steel pushrods are guided down through the casting, seating directly onto the camshaft lifters hidden below. The complex rocker arm assembly is then lowered over the valve springs. As the securing nuts are torqued down, these arms will act as levers, translating the upward thrust of the pushrods into the massive downward force needed to open the valves. Feeding a diesel engine requires a precise network of high-pressure steel plumbing. Rigid metal fuel lines are meticulously routed along the exterior of the block. The small connection nuts are threaded exclusively by hand to avoid stripping the delicate brass fittings. A wrench provides the final, firm tension required to lock the tapered ends securely. These hard lines will carry violently pressurized diesel from the pump directly to the injectors, demanding an absolute, leak-proof seal at every junction. The exterior mechanical systems are rapidly coming together. The heavy cast iron exhaust manifold is bolted tightly against the cylinder head flange. This thick casting is designed to endure extreme exhaust temperatures without warping or cracking under constant thermal shock. At the rear of the crankshaft, the massive clutch pressure plate is hoisted onto the flywheel. The heavy internal steel springs within this plate provide the sheer clamping force necessary to lock the engine's rotational power directly to the transmission. Aligning the heavy unit requires careful, centered positioning before the mounting bolts are driven home. Moving around the exterior of the block, dozens of small linkages, retaining clips, and secondary fuel bolts are methodically addressed. Every single fluid fitting is double-checked with a wrench. A loose connection on a heavily vibrating diesel engine will quickly back out, inevitably leading to catastrophic fluid loss in the field. The core power plant is fully built. Before the block can be permanently sealed, the mechanical timing must be perfectly dialed in. Using a specialized adjustment tool, the precise clearance between each rocker arm and valve stem is set to exact factory tolerances. If set too tight, the valves will quickly overheat and burn. Too loose, and the valve train will violently rattle itself to pieces. With the clearances firmly locked in, a continuous bead of liquid sealant is traced across the top flange of the cylinder head. The brightly polished metal valve cover is pressed downward into the wet silicone, forming a custom, permanent oil barrier. Tightening the top bolts evenly ensures the cover won't warp. A final throttle linkage bracket is mounted to the casing, completing the fully sealed engine assembly. Bare cast iron and raw steel will immediately begin to rust if left exposed to the ambient humidity. A pneumatic spray gun applies a thick, uniform coat of high-temperature black enamel across the entire engine assembly. The paint bonds tightly to the meticulously degreased metal, sealing out moisture and preventing deep corrosion. Coating the intricate exterior fuel lines and the tall vertical exhaust pipe creates a striking, unified barrier. The engine now sits as a massive, glossy black monument of restored mechanical power, curing in the open air. With the engine fully cured, attention shifts to the tractor's heavily neglected driveline. A long pry bar is wedged deeply, between the rusty cast iron seams, cracking the hardened seal on the rear transmission housing. Pulling the massive casing away from the main chassis exposes the complex internal gear sets, which are still dripping with thick, contaminated gear oil. Placing the heavy unit onto a scrap tire provides a stable, cushioned base for further teardown. Every oxidized chassis bolt fought here requires severe manual leverage, preparing the bare frame to eventually receive its restored power plant. After thoroughly flushing and inspecting the internal gear sets, the massive transmission housing is hoisted back into alignment. Suspending the heavy cast iron unit from a rope allows the delicate input shafts to be perfectly guided into the chassis splines without binding under their own weight. The thick metal top cover is carefully lowered into place, sealing the complex gear set away from field dust and water. Fastening this heavy cover requires an alternating bolt pattern to ensure the casing sits completely flat. An impact driver rapidly runs the hardware down, while a precision torque wrench guarantees the exact structural clamping force required. Underneath the chassis, the final heavy mounting bolts are driven home. The two halves of the machine are finally ready to be joined. The suspended transmission housing is pushed forcefully forward, mating precisely against the back of the freshly painted engine block. The splined input shaft must slide flawlessly through the clutch friction disc and seat deep into the flywheel. Once the heavy cast iron faces sit perfectly flush against each other, the tractor's structural integrity is restored. Heavy-duty bolts are driven through the bell housing with an impact driver, permanently locking the engine and transmission together into a single, rigid backbone. Tightening the exterior side linkages guarantees the heavy mechanical connection will easily withstand the severe torque of fieldwork. Restoring operator input requires mechanically linking the external levers to the internal shift forks. A thin steel linkage rod is secured to the transmission control arm with a simple retention pin, immediately re-engaging the gear selection mechanics. With the complex linkages properly routed and tightened down, a sleek black cover plate is mounted over the center console. This crucial plate will shield the delicate transmission joints from falling dirt and harsh weather. The visual transformation accelerates rapidly as the bright red bodywork is introduced. A heavy steel fender panel is positioned over the rear tire well. This structure isn't merely cosmetic. These thick metal guards protect the operator from flying mud, rock strikes, and the massive spinning rear tires. Working flat on his back beneath the frame, the heavy steel support brackets are bolted tightly to the rigid axle housing. The fenders must be heavily reinforced to prevent them from vibrating and eventually stress cracking under the constant, heavy rumble of the diesel engine. The vibrant red paint strikes a sharp contrast against the dark mechanicals. The operator's station demands solid, unyielding mounting points. A heavy steel base bracket is impacted directly into the chassis frame to support the driver's seat, designed to absorb the constant jolts of rough agricultural terrain. At the center console, the shiny gear shift pattern plate is carefully aligned over the bare metal levers. This stamped guide is crucial for navigating the complex, high and low range transmission gears without accidentally grinding the synchronized teeth. Securing the thin plate with small screws locks the shift gates permanently into position. The cockpit has transformed from a raw steel skeleton into a finished workspace. Mounting the heavy fuel storage requires a highly secure, vibration-resistant fit. The black polymer tank is nestled into the top brackets and locked down with a tensioned metal strap. This flexible mounting system prevents the rigid fuel cell from fracturing as the tractor chassis twists and flexes over uneven ground. Bolting the strap tight locks the massive reservoir firmly over the block. The tractor's aggressive stance is finalized at the front end. Ratcheting the heavy lower pivot bolts locks the solid front axle assembly directly into the main frame. This thick cast iron beam must endure the entire forward weight of the heavy engine while violently pivoting over deep ruts. With the robust steering knuckles tightly secured, the bright red front wheel is lifted onto the hub. Sliding the heavy rim over the threaded wheel studs completes the rolling chassis. After being suspended on wooden blocks, the machine finally stands entirely on its own rubber. A diesel engine running under maximum load generates immense thermal energy, demanding a high-capacity cooling system. A black metal shroud is bolted closely around the mechanical fan to force incoming airflow straight through the radiator core, maximizing heat extraction. The heavy radiator unit itself is lowered carefully into the front chassis mounts and secured with hand-threaded bolts to prevent stripping. Thick rubber coolant hoses are stretched tightly over the inlet ports and clamped down hard with steel screw bands. These reinforced hoses must safely contain boiling, highly pressurized fluid circulating rapidly from the block. Above the cooling stack, the wide black air intake pipe is routed toward the front grille. This vital tube will draw cold, dense oxygen directly into the cylinders, vastly improving combustion power. Securing the final support brackets ensures the entire front assembly won't vibrate loose. The massive red steel hood is bolted securely to its forward pivoting brackets, finally enclosing the raw engine bay in a sleek, protective shell. With the heavy armor in place, the delicate electrical system can be carefully routed. The wiring connects the dashboard instruments and the new voltage regulator directly to the engine's vital sensors. This thin web of copper wire is highly susceptible to melting or fraying. Using heavy plastic zip ties, the cables are pinned tightly along the rigid steel frame, routing them safely away from the spinning fan blades and the scorching exhaust manifold. A single exposed wire grounding out against the bare chassis could instantly kill the entire electrical system in the field. settling. Into the operator's seat, a firm twist of the steering wheel verifies the mechanical resistance of the new linkages. The heavy cast iron steering box translates the rotation perfectly down to the front axle, leaving zero loose play in the joints. The final static preparation before ignition is fueling the dry machine. Fresh, amber diesel is poured heavily through a filtered funnel into the tank. This clean fuel will flood the mechanical injection pump, priming the high-pressure steel lines for the absolute first time in decades. Under the heavy steel hood, the final, crucial electrical connection is secured. Tightening the metal clamp fiercely over the lead battery terminal guarantees the massive surge of cold cranking amps required to rotate the heavy diesel block. The hood is dropped and latched tight. Pushing the mechanical throttle forward, the resurrected machine tears forcefully into the tall, overgrown field grass. The aggressive rear treads bite deeply into the soft soil, effortlessly driving the heavy iron frame forward through the resistance. What was recently a seized, rust-welded scrap pile is a working machine again, revived, immensely capable, and honest about its agricultural roots. Every hidden bearing they meticulously greased, every exact clearance they measured, is what its newfound reliability now firmly rests on. Structure, steel, and combustion operate perfectly as one system. Some things are absolutely worth the long, hard road back.